Question 1, you are asked to show that the two lines L1 and L2 intersect and find the point intersection. And part B, you are supposed to find the acute angle between L1 and L2. Part 3, you are supposed to show that the point 337 does not lie on the line L1, and then find the foot of perpendicular from A to L1. To show L1 and L2 intersect, you can just equate the equation of L1 with equation of L2. So that's what I'm going to do here. So equate the equation of L1 with L2. Then after that, you compare the item. So 1 plus 2 lambda will be 4 plus mu. Compare J term, 1 plus lambda is J, so it's 1. So 1 plus lambda is 1. It tells you lambda is 0. And then you can compare the K term. 1 plus lambda is 10 plus 3 mu. Remember, we have found lambda to be 0. So if sub lambda is 0, you can solve for mu. Lambda is 0, so you can cancel this term. So from here, you can mu is 1 minus 4, so minus 3. Same thing, you cancel the lambda term. 3 mu is 1 minus 10 is minus 9, so mu is minus 3. So both equations give you mu equal to minus 3. Yeah? So which means the three equation has a unique solution. So L1 and L2 intersect. And you can just sub lambda as 0 into the equation of L1. So lambda is just put as 0. So which means the intersection point will be just I plus J plus K, position vector. So intersection point should be just 1, 1, 1. Next, you need to find the acute angle between L1 and L2. If you draw two lines L1 and L2, right? And after that, it might happen that the direction vector of L1 is pointing this way. So let's say 2I plus J plus K is pointing this way. Then L2, right, the direction vector I plus 3K is pointing this way. Then the angle between L1 and L2 will be an obtuse angle. And it will give you acute angle if you just take the two direction vector of the line and then you find the angle between them. So to find acute angle between L1 and L2, you cannot just take the direction vector and take the dot product. Use the dot product to find the cosine theta. It might give you an obtuse angle. So which means if you just take U1, so this one I call U1, this one I call U2, right? If you find cosine theta equal to U1 dot U2 over magnitude of U1, magnitude of U2, right? It might give you negative, which means the angle between L1 and L2 is actually obtuse angle, because the direction vector U1 and U2 makes an obtuse angle between each other. But if you want to talk about angle between two lines, acute angle, what you want is this angle, the acute angle. So to have acute angle, right, cosine theta will be, the acute angle theta is between 0 and 90. So which means cosine theta will be positive. So you should take magnitude, then you give you acute angle. So that's why we consider cosine theta equal to magnitude of U1 dot U2 over magnitude of U1, magnitude of U2. So if you work out the dot product of the two direction vector of the two lines and take magnitude, you'll find that cosine theta is square root of 15 over 6. So you can find theta is just cosine inverse of square root of 15 over 6. In part C, I want to show that the point 337 does not lie on the line L1, and then find the foot of perpendicular from A to L1. So anyway, this is L1. A is the point 337. So we're going to show A is not L1, and then you find the foot of perpendicular. So we're going to find the point P. To show the point A does not lie on L1, you can suppose the point 337 lies on L1. Then 3i plus 3j plus 7k should satisfy equation of the line L1. The equation of line L1 is I plus j plus k plus lambda bracket 2i plus j plus k. So that means you just equate this to 3i plus 3j plus 7k. Then you show that you cannot solve for lambda. So if you equate the equation of line of L1 to 3i plus 3j plus 7k, if you compare I component, 1 plus 2 lambda will be 3. If you compare j component, 1 plus lambda will be 3. K component, 1 plus lambda is 7. And from here you see that it's not possible because 1 plus lambda equal to 3, and 1 plus lambda cannot be equal to 7. If you solve for lambda from each equation, you get lambda is 1 from first equation. From second equation, you get lambda is 2. From third equation, you get lambda is 6. So we have a contradiction. So with that, you can say A does not lie on L1. After that, you're supposed to find the foot of perpendicular from A to L1. You can let it be P. And then, because P lies on L1, the position vector OP must satisfy equation of the line L1. So OP must be of the form I plus j plus k plus lambda 2i plus j plus k for some lambda. So that's how you get this part, because P lies on L1. And then you can find OP, AP. AP is vector OP minus vector OA. So just take this, the position vector OP minus 3i 3j plus 7k. Will give you this vector in terms of lambda. Because P is the foot of perpendicular from A to L1, AP will be perpendicular to L1. So that means you can say AP perpendicular L1. So AP dot with the direction vector of L1. So this is the direction vector of L1. So direction vector of L1 must give you 0. So if you look at the dot product, it will give you 6 lambda minus 12 equal to 0. So lambda is 2. So you just have lambda equal to 2 into the equation of L1, and you will find the position vector of the foot of perpendicular from A to L1, OP. So OP is 5i plus 3j plus 3k. So P is a 0.533. So that's how you find the foot of perpendicular from A to L1.